Hi, grade 12s. We're going to take a look at how to assign oxidation numbers for organic compounds. So to do this successfully, it's best to draw the molecule. Um, so this will be drawn for you actually on a test when there are, more complicated structures. Because the purpose is to determine the oxidation state, not necessarily to have you draw it correctly yet. So the way this is done is you have to give the more electronegative element the electrons. That's pretty much the same strategy that we were using in the last video when we assigned, for example, oxygen a charge of -2. It's because it's usually paired with something less electronegative, so it takes the electrons from that element. So it's a similar idea here. So you're starting with the carbon. Carbon is paired with 3 hydrogens and then another carbon, or bonded to rather. So because carbon is more electronegative than hydrogen, it will take hydrogen's electron, each of these 3 hydrogen electrons, and then therefore end up with a charge of -3. Here it's bonded to itself, and so because they have equal electronegativity, we just divide the electrons equally among them, and since this electron was originally carbon's, remember that it has 1, 2, 3, 4 valence, it's not gaining or losing it belonged to it, so it's not going to give it a charge. The charge of -3 it gets because it takes that electron over there, that one from hydrogen, and that one. A total of 3 electrons added mean a -3 charge. Likewise, hydrogen will end up with a +1 charge because it has lost each of these have lost their electron to carbon. So looking now at this carbon here, it's less electronegative than oxygen. So both of its electrons which are there are going to go on to that oxygen. And so it will develop a -2 charge. And carbon, having lost its 2, will be +2. Although it is bonded here to this oxygen, and will also give that electron, its third electron, to that oxygen, so it ends up with a 1, 2, 3, +3 charge. Again, this one is sharing with itself, so it's not going to be able to take from that carbon. Since oxygen here takes from this carbon, it ends up with a -1. It also takes from that hydrogen, so there's its -2, and this hydrogen is +1. So looking at this structure over here, fluorine is bonded to oxygen, and fluorine is more electronegative, so it actually takes from oxygen, making it a -1. Oxygen would be +1 by virtue of having given that electron to fluorine. And then over here, it actually takes from carbon because it's more electronegative, giving it a -1. A +1 and a -1 mean overall oxygen is neutral. Remember that these oxidation states are not true charges because these are all covalently bounded. They're sharing electrons. They're imaginary charges that we assign to the elements as if they would become ions, or what ion they most likely become were that to happen. It's a way of keeping track of electrons for the purposes later on of being able to balance reactions. So here we have carbon, which just lost its electron to oxygen. It's going to lose these 3 to nitrogen, and so those go to nitrogen. It'll end up with a +4 charge. Nitrogen will end up with a -3, having taken carbon's 3 electrons. So this last molecule here, let's try this one. Fluorine will be -1, stealing from carbon, pardon me. Carbon is going to steal from hydrogen, being -1, but then it's going to give these 2 to oxygen, so that'll be +2, +1, -1, make an overall charge of +1 on that carbon. These disappear. Oxygen, of course, will be -2 here, and hydrogen will be +1. One way to check that your structure is correct is to make sure that all the charges are balanced. If the compound is neutral, then all the charges have to add up to 0. If it has an overall charge, then all the charges have to add up to that overall charge. So over here, back over here, we had -1, 0, +4, -3. So 4 positives and 4 negatives would make a neutral compound. Let's see if this one's been done correctly. So actually, I don't think I ended up finishing this one. So -1, and I can tell from the charges. -1 and -2 is -3. Hydrogen here is +1. We assigned a +1 to that carbon, so that's not correct because the charges don't balance. So let's take a look at that again. So fluorine will take from this carbon. Let me redraw it actually. So fluorine becomes -1. Carbon takes from this hydrogen. That means it's -1. And then it gives these 2 to the oxygen, -2. Sorry, +2, my apologies. And then what we forgot last time is that it gave to fluorine, so that would mean it's +1 there. So +1 and -1, that cancels, so it's actually +2. Hydrogen here is +1. And then this over here, oxygen is -2. So you can see now the charges are balanced. -2, -1 is -3. +2, +1 is +3. So it's a good idea to add up all the charges as a way of checking to see that you've done your assignments correctly.